Hi, welcome to the Shuko Math Lab differential equation problem solving section. All right, so here is the problem we're going to solve today. So it's x squared y prime plus 2x cubed y, and it's equal to y squared times 1 plus 2x squared. Okay, with the initial condition, y1 equal to 1/2. Okay, so let's go ahead and take a look how we approach it. So just like we mentioned before, every time when we start to solving the differential equation, the first thing is let's observe what will be the best potential candidate we can, formulas or methodology we can use. So we observed here, this is the y prime, this is the y, and this is the y square. And then also all the constants in front of it here. This is x squared, 2x cubed, and 1 plus 2x squared. So these ones give us a very good, kind of the hint. So I think this one will satisfy the Bernoulli equations here. So maybe we can try to solve it by the Bernoulli equation. All right, so here, like we always do, if I think this is Bernoulli, let's write down the Bernoulli. The formula is dy dx equal to the pxy and equal to the qx y to the n. All right, so the first thing is here, we have this x squared in front of my dy dx. So let's try to divide by x squared both sides. Okay, so for the first ones here, I will have x squared y prime. So let's divide by x squared. So the first term become dy dx. I like to write the y prime to the dy dx. All right, and then the second terms here is x cubed, right? So this is plus 2xy. And then the last ones here, this is y squared. Then this is 1 plus 2x squared, x squared. Okay, so now in here, this is, let's try to match my Bernoulli's. So this will be my px, right? So this is my px, okay? And this will be my qx, correct? And my n's here, n is equal to 2. After we identify this is the Bernoulli equation, then we can just follow the typical step-by-step process. So let's do it one more time. So step number 1, what is step number 1? Let's define a new variable v is equal to y, the 1 minus n. Okay, so it's equal to 1/2. Then the same things here. Then I take the derivative is dv dx is equal to negative y to the negative 2 dy dx. Or you can rewrite this is negative 1 y squared dy dx here. All right. So then the next steps here is okay, so I want to replace the dv dx. I want to isolate the dy dx. So the dy dx will just be times negative y to y squares, right? So it's times negative y square, both sides. So this is dv dx, right? Because in here, okay, so so here that means times the left-hand side with negative 1 y square, and the same things here I times negative 1 y square. So these two, right? So these two cancel. So that's why I replace the dy dx to a function, to be used as dv dx. So remember the step number 2 is I'm going to replace my original differential equation. So let me try to highlight that. Okay, so this is the, right, so this is my original, this was my original differential equation. So I want to replace the dy dx with what I got here. Right, so I want to replace the dy dx with here. All right, so now I can have negative y square dv dx. That's right, because the dy dx equal to negative y square dv dx. Everything else remained the same. 2xy is equal to y square. And then here, this will be x square and 1 plus 2x squared, right? 1 plus 2x squared. Okay, so now the next things here, I'm going to, change that to the standard, the first order linear differential equation. So what I need to do, I need to divide by negative y square in the front. So I would just want to have dv dx, right? So that means I need to do is I need to multiply negative 1 over y square both sides, right? Negative, so I will times negative 1 over y square both sides. And so this cancel, and so here this will be plus, so the plus and the negative become negatives, right? So I need to be very careful about my algebra. So this is negative 2xy, all right? So it's negative 2xy, and then here the y squared and here cancel, so will be negative 1 plus 2x squared to the x squared, okay? And then I'm going to, because the v is equal to the 1 over y, so I can change this is dv dx minus 2x 1 over y is here, right? 1 over y is here. So times v, okay, is equal to negative 1 plus 2x squared and x squared. Okay, so now this is our standard, the nonlinear and standard linear first order differential equation. So what is the next step? Next step, after we do that, is next step we want to find the integration factors. So remember, how do we find the integration factor? So this is also a typical standardized step. So we said du dx is equal to this numbers here. This is my new px's, right? So it will be negative 2x times u. Then I want to solve in for u. Solve for u, then I can do the separation technique because it's pretty straightforward. So that's why will be du over u equal to negative 2x dx. Okay, so now I integrate. So I will get a natural log u is equal to negative x squared. Okay, now I take the e both sides, so I will say u is equal to e to the negative x squared. Okay, so now after I did this, what I need to do? Okay, so let me highlight my new, my new equations here, right? So here, this is my, okay, so this is my new first order. So I'm going to multiply, like we always did, multiply this on both sides here. All right, so my equation will going to be e to the negative x square dv dx. All right, so this is dv dx is equal, then minus times here, this is 2x e the negative x square v, then is equal to e to the negative x square times, okay, so times e to the negative square times, got a negative sign here, times negative 1 plus 2x square, x squared. Okay. Okay, so like before, okay, so we know this one's here, I can rewrite this one's here. We can rewrite this one as the derivative of a product rule, right? So this is e the negative x squared dv dx, and then this is the derivative of e the negative square. So this is the product, so this is negative x squared v, right? So this is e the negative v is equal to, okay, so it's equal to, I move this negative in the front. So it's negative e to the negative x squared times 1 plus 2x squared x squared. Okay, so now this one's here. Okay, so now I can integrate both sides here. So let me simplify this one a little bit. So this is negative e to the negative x squared. And this is 1 over x squared plus 2. Okay, and now in here, now I integrate both sides. I integrate both sides here. Okay, so this one is a derivative, then integrate, so this will just be itself e to the negative x squared and v. And then here, this will be the negative e to the negative x squared. Then this is 1 over x squared plus 2. All right, dx. You know, when I first try to start integrate these integrations, and then I find out that, I tried a different method and I find out it's very difficult to do. Then I suddenly spot some things here. Okay, so I suddenly spot these numbers here. Okay, so this one's here. All right, so this one's here. It's kind of like it's kind of like this is the derivative. It's kind of like the product rule concept again. So it's 1 over x e to the negative x squared. So now in here, this is the product rule, right? So if I use the product, so hold one thing, so the negative 1 over x, so the derivative is negative 1 x squared e the negative x squared, then plus 1 over x, then the e to the negative x squared, then chain rule is negative 2x. So so negative 2x. So what I had here? So I had here is negative, or if I take the negative out, all right, so then this will be the negative, and also I can take the, okay, so I can factor the negative out. All right, so here I can factor the negative and the e to the negative x squared out. So see here, what I have here, this is 1 over x squared, then plus 2 here, because this x is canceled. So I know the whole these things I can rewrite as the 1 over x e to the negative x, the derivative of that. So now, since I can rewrite that, okay, so here, now I can, so if this is e to the negative x squared b, so my right-hand side will just be what? My right-hand side is, because this is a derivative of this product rule, so now I integrate that, so it's basically this side will just give me is 1 over x e to the negative x squares here. All right, and now I can, now the things here, the v is 1 over y, right? So here this is e to the negative x squared 1 over y, right? So it's equal to 1 over x e to the negative x squared, okay? Of course, here I need a plus c's, right? So this is a plus c. Okay, so now I can times both sides. So I can times the both sides to the e to the x squared. So here I can times e to the x squared. So my left-hand side, so this disappears. So it's 1 over y. Okay, don't forget that plus c's here, right? So now in here, and here this will be equal to, this cancel is 1 over x, okay, plus c to the e to the x squared. Okay, so now my initial conditions, right? My initial condition is y1 equal to 1/2. So here y, so y1 over y, so this 2 is 1 plus c times ce. Okay, so that means CE equal to 1. So my constant C is 1 over E. All right, so now I finally got my solution. So I will say 1 over Y is equal to the 1 over X plus 1 over E. All right, so 1 over E and times e the x squared. So then here I can simplify this is a little bit. So it's 1 over x plus e is 1 over e, I can say is e to the negative 1, right? So this will be plus e the x squared minus 1. So finally my y value, you just flip it over. So it's 1 over 1 plus x plus e the x squared minus 1. That's it. Okay, so I think the hardest part for this problem is this step here. Okay, so it's this step. Okay, so if I did not spot, this is the result of a product rule of the function, the derivative of the product rule of the functions, right? So I tried integrate by parts, integrate by the substitution use up, and the other different type of integration. I have trouble to get it. So after I spotted it, I thought, well, that's great. Okay, that's it. I hope that this will help you try to help solve your problems. All right, so have a good day, and I will talk to you, and we'll work on other problems the next time. Okay, bye. Have a good day.